Alrighty, and welcome back. So today we are going to be starting a new unit packet. It's still within Unit 1. Unit 1 is broken up into a few different parts. So if you want to take a look at our Unit 1 Functions Part 2 packet, we are going to get started. So we are going to be looking at page 36, and we're going to be talking about shifting functions and completing the square today. All right, so to start us off, we're going to start by identifying and sketching each graph by first probably identifying the vertex. That's going to be probably most helpful for us. So for our first graph here, I noticed that there's a negative out front, which indicates to me that this thing is reflected over the x-axis. And we have this +3, which means we have a vertical shift up by 3. So I'm going to start by creating my first point there because I know that the parent function of this is this graph. Then we go up 3 over 1. This is what the parent function looks like. So this is the parent function of x squared. You don't need to graph that. I'm just using that as a reference because now what I want to graph is actually this. So I'm going to shift it up by 3 after having reflected it over the x-axis. So picture reflecting this over the x-axis. We're going to go down 3 over 1. Okay, down 3 over 1. So picture having reflected this over the x-axis and then shifting it up by 3. And then you're going to plot those points. Okay, I know I'm drawing this on an iPad, so it's a little difficult, but try to make that as smooth of a curve as possible. And if I look at the vertex, that's our turning point, which is at 0, 3. Okay, and it's a maximum. Okay, let's take a look at question 2. So I noticed there's that 2 on the outside, which tells me this is a vertical stretch. And with vertical stretches, these get narrower, okay? So if I were to consider this, compare this to the parent function, ready? I'm just graphing the parent function right now. This is up 1 over 1, up 3 over 1, up 3 over 1, and then up 1, 2, 3, 4, 5 over 1. Okay, so that's actually, I don't know if I've mentioned this already, but that's the pattern for a quadratic. If I'm looking at the y to x values, I go up 1, right 1. Go up 3, right 1, and go up 5, right 1. So that's the pattern for following a quadratic x squared. Okay, so I went up 1 over 1, up 3 over 1, and then up 5 over 1. Okay, so this is what just the x squared graph looks like. So I know once I apply that 2, it should be a lot narrower, something more narrow. Okay, I just drew that as an example. Right now I'm going to leave the parent function out front. Okay, so we always want to follow our order, which is high school RV. So I'm going to do the horizontal shift to the left first. So I'm going to move this over to the left by 1, 2, 3, 4, 5, 6. So let's do that. Move all the points over. And I'm starting off with the parent function. Okay, so I just moved it over to the left by 6. Now I want to stretch it by that factor of 2. So I'm going to erase the blue because we don't need that anymore. We used that for the parent function. Okay. And remember, with the vertical stretch, nothing happens to the x values. It's all the y values that are going to double. So if we look here, nothing happens to the x values, but the y values double. So instead of this y value being at 1, I'm going to now have a y value, let's do it in pink, at 2. Instead of being at 4, I'm going to have a y value all the way up at 8. And then similarly over here, instead of being at positive 1, I'll be at 2. And then instead of being at 4, I'm going to be at 8. Okay, so that's now what my new graph looks like. And there's no actual point there. Sorry if that looked confusing. Okay, all right. And now, for my last step, I'm going to do the vertical shift. Okay, the vertical shift happens last, so I'm going to bring this down by 5. 1, 2, 3, 4, 5. So I'm going to bring this all the way down. Okay, so I'm moving it down by 5 units, so I have a point here. We went up 2 over 1, and notice, guys, really, we're just multiplying these by 2. So instead of going up 1 over 1, I go up 2 over 1, up 6 over 1, up 10 over 1, but we're not going to actually reach 10 over 1. Okay, so up 2 over 1, up 1, 2, 3, 4, 5, 6 over 1. All right, and then again, up 2 over 1 on the left, and then up 1, 2, 3, 4, 5, 6 over 1. So there is my new graph, the blue. So I'm going to erase the pink. Okay, tried to draw that as best as I could. And now our vertex is located at, let's see, -6, -5. So there's our vertex. Okay, awesome. And again, as we noticed, this became narrower because of that vertical stretch. And you guys can try question 3. I'll just draw what the final graph looks like, but I'm not going to go through explaining it. You can try that one. Okay, and that's what the graph should look like. Guys, just remember, listen, I make mistakes too. So if you catch a mistake, you really think that you're truly correct and I'm wrong, let me know. Maybe I'll award you a bonus point here and there, all right? Okay, so now that we've had just a little bit more practice with our shifting of functions, as we did in our previous lesson, that was a little bit of a warm-up practice, let's get down to business of completing the square. So I'm going to show you guys another way to complete the square. You have probably seen this one and only one way. I'm going to show you another way, and if you don't like it, you don't have to do it. I had students last year who said they preferred the method that I showed them. Great, and if you don't have to do it. You can do it the way you've always been taught. So let me show you first and foremost the way that you've always been taught. So when you guys complete the square, you guys always said, oh, okay, I got to add the constant to the other side. So I'm going off of the way you've always been taught. Add the constant to the other side. X squared plus 4x plus you fill in the blanks equals y plus 5 plus fill in the blank, right? You'd always add those blank spaces on either side. Okay, so a little bit of review for complete the square. Then what you guys would always do next is we would have the b term, and then square it. So have the b term, square it. 2 squared is 4, so we're going to add 4 to both sides. We end up with y plus 9. Okay, 5 plus 4 is 9. And I'm just going to rewrite this as x plus 2 quantity squared equals y plus 9. We want to get y by itself, so I'm going to subtract over the 9. Plus 2 squared minus 9 equals y, right? Bring over the 9. And that's it. And in vertex form, if we were to write the vertex, okay, we take the opposite sign of what's inside the parentheses here. Oops, didn't mean to erase that. Of what's inside the parentheses here. So if this is positive, we're going to take the opposite. So this is going to be -2 comma -2. So that's my vertex. Okay, so that's the old school way. That's like the way you've always been taught how to do it. For question 5, which we're going to do together, I'm going to show you how to do this a different way. So whenever you complete the square, the first thing is always that x, the number in front of x squared always has to be a 1, which it was in this first problem. But that's not the case here. Right now the number here is 4. So what we're going to do is divide everything out by 4. Okay, now I know this probably looks a little weird because you're like, well, why is this y over 4? Don't worry about it, just leave it. Okay, this equals y over 4, just leave it. Okay, now, to do this a little differently, and the reason why I teach it like this is because it's less steps. Really, in this method here, you guys are adding 2 extra steps. So I'm going to cut it out. What I'm going to do, because you guys are always used to bringing that -8 over, right? You would bring the constant over. We're not going to do that this time. What we're going to do, right, let's put that back. What we're going to do is I'm going to add my blanks on the same side of the equal sign. So I'm going to do my x squared minus 2x plus blank minus 8 minus blank. Okay, so all I did was what you guys did over here, right? We added the 4 here, and then we added it to the other side. So I'm doing the exact same thing, except instead of adding that 4 to the right, I'm saying just subtract it out on the same side of the equal sign, right? I'm just making up a number here, but if I said, hey, add 2 here and subtract 2, I didn't change the problem, okay? So that's all I did, was I'm just keeping it to being less work. All right, well, always with completing the square, we have it, square it, so have the b term, and then square it. 1 squared is 1, so if I add 1 to one side, I still have to subtract out 1 on the same side of the equal sign. And now we can simplify. -8 minus 1 is -9, which equals y over 4. And then the last thing we have to do is multiply that 4 back out to everything. So we'll be left with 4 times x minus 1 squared minus 9 times 4, that's -36, which is equal to y. So there is my equation. I cut out 2 steps, guys. And lastly, to write this in vertex form, remember we take the opposite sign of what we see inside the parentheses. So this will be 1 comma negative 36. And that's it. All right, let's get some more practice in here. So let's flip over to the next page. And let's do number 6 together, okay? I'm starting these off with doing them more so together with you guys just to get you into the hang of it. Okay, so again, few ways you could do this. I'm going to show you it representing it my method. So I have x squared minus 12x. I'm actually going to bring the 13 over. Minus 13 equals 0. I'm going to then write in my next step, x squared minus 12x plus the blank minus 13, and then minus the blank. Keep it on the same side. All right? So again, if you want to do the plus on both sides, totally up to you, but this is typically how I teach it. Okay? Again, it's just something new. Like you're not used to seeing it like this, so it might look a little weird. All right, we're going to have it square it. So have the b term, which is minus 6. 6 squared is 36. If I add 36 here, I have to subtract it on the same side. So minus 36. And negative 13 minus 36 is negative 49. And look, this is already in vertex form. Our vertex is going to be 6, negative 49. And that's it. All right, why don't you guys try question 7? And for question 7, all right, I'll just post what the final answer is. So your final answer, when you simplify this, you have x plus 4 squared minus 1 equals 0, and the vertex is negative 4, negative 1. Okay, but again, you guys have to show the work. I'm going to skip over this section right here, 8 through 10. This is more practice with graphing without a calculator. I would try these on your own if you so choose, but I'm not going to spend the time to do that right now because we did a bunch of transformations and translations in our previous lesson. So we're just going to continue with completing the square. So why don't we all turn to page 38. Okay, so I'm going to do another one with you guys. So question 1, again, that a value cannot be bigger than 1. If it is, we have to divide out by everything. So it has to be 1. So we're going to divide everything out by 2. Everything gets divided out by 2. So I have x squared plus 4x plus 7 over 2 equals negative 1. I'm going to bring over the 1. I can really rewrite this as plus 2 over 2. Plus 2 over 2. Right, because negative 1, I'm trying to get rid of it, so add it to the other side, and 2 over 2 is just 1. So I have x squared plus 4x plus 9 over 2. Guys, you shouldn't be using your calculator for any of this. Okay, using the method I just described to you. Now, I actually am going to erase what I have here just to make some space. All right, so again, using the method that I showed you, I'm going to do x squared plus 4x plus blank plus 9 over 2 minus blank equals 0. Don't forget, we divided everything out by 2, so don't forget about the 2. I want you to leave it there because we have to remember to multiply back. All right, we're going to have it square it. So half of 4 is 2. 2 squared is 4. If I add 4 here, I better be subtracting 4 on the same side of the equal sign. Now, I am just going to rewrite 4 if I want to divide it by 2. I'm going to really just write this as 8 over 2. 8 over 2, that way these have the same denominator. Okay, combining like terms, I'll have plus 1/2 equals 0 over 2. The reason why I'm leaving this as 0 over 2 is because I have to remember to multiply everything back by 2. Everything gets multiplied back by 2. So this is what my final answer should look like in vertex form. And then just lastly, the vertex here is negative 2, positive 1. All right, you guys are going to do questions 3 and 4, and the last one I'm going to show you is question 5. Okay, so for question 5, I want to get my 7x brought over. So now I have 4x squared minus 7x minus 1 equals 0. And what do I want to do next? Okay, well, again, this cannot be 4, so divide everything out by 4. Now, you guys are in pre-calc, so there will be questions where the function maybe doesn't have as nice of a number. You're going to have fractions sometimes. So when I divide everything out by 4, I have x squared minus 7 over 4x minus 1/4 equals, leave the 0 over 4. I leave that there as a reminder to multiply it all back. Okay, I'm going to use the method that I typically like to use. If you want to go ahead and add to both sides, be my guest, you are still going to get the same answer. Okay, equals that 0 over 4. I'm just subtracting and adding to the same side. So remember, we have the b term, and we square it. So half of 7 over 4, well, that's really keep, change, flip. That's 7/8. So I have x minus 7/8. I want to square that now. 7 over 8 squared is 49 over 64. Got to know your perfect squares. And then we're going to subtract out 49 over 64. Okay. I'm going to change this 1/4 here. I'm going to change this 1/4 and rewrite it so that it has the same denominator as here. So it has the same denominator as 64. So if I multiply this 1/4 on top and bottom, so I'm going to multiply top and bottom by 16, trying to fit that in. So this is really going to be minus 16 over 64, minus 49 over 64, so this whole thing, equaling that 0 over 4. Keep the 4 there because you got to remember to multiply back. Okay, and continuing, combine like terms. Negative 16 minus 49, that is minus 65 over 64 equals 0 over 4. And we just have to remember at the very end, multiply it all back by that denominator, the whole thing. So I'm left with 4 times x minus 7/8 squared. This is getting multiplied by 4, which leaves me with minus 65 over 16, which equals 0. So there is my final answer in vertex form, leaving our vertex to be 7/8 and then negative 65 over 16. All right, so like not the nicest of numbers, but you guys are totally capable of reducing fractions. I will post the answers right now for 3 and 4 so you can check your answers. Alrighty guys, and just check your solutions, make sure they end up with the correct answer in the end. Alrighty, that takes care of completing the square for today.